Okay guys, so we are officially done with all of our algebra lessons, and we're going to go ahead and go into some pre-calculus topics. So for today, we are going to be with lesson 1, and we are going to be talking about the function notation, domain and range, right? So this will be identified as the function basics. So before we begin, let's go ahead and read this little box that I have right here. Okay, so the most popular function notation is f of x, right? Which we already know because we've used it this whole year. Now, how do you say f of x? Well, you read it such as that, f of x. Okay, now an important thing right here is that this is not the multiplication of f times x. Okay, so whenever you see f of x, that is not multiplication, okay? So f of x does not mean, it does not mean multiplication. Okay? So what are some advantages of function notation? Okay, some advantages of function notation are that it allows for individual function names, so that way we can avoid confusion between functions. So for example, you can go ahead and have f of x and g of x, right? And you won't confuse the two. When you do this in the graphing, well, no, that's actually for like the older models. It also helps you with identifying the independent variable, right? So you can get this function right here, and you already know the variable that we're going to be dealing with is x. We don't care about b or c. We want to know what the x value is, right? Or we might actually care about b and c, but in this situation, we know that the value that if we ever do try to find is going to be x, the independent variable in the problem. It also helps us state the elements of the function to be examined. So we have something like find f of 2. When you get this function, that means that we want to find y when x equals to 2 for y equals 3x. Now, these are the types of problems that we're going to be dealing with today, right? You also have this right here that tells you have f of x equals to 3x plus 1. Well, the value inside the parentheses right there, that is going to be your input value. And then once you input it into the right side of the equation, then that right there will give you the output value. Okay? So you're going to be using the input value to figure out what your output value is. Okay, and there's like multiple ways to write this, right? You can use y equals 3x plus 2. You can also use f of x instead of y. F of x is the exact same thing as y. We've also seen not this exact format before, but there's things in this format that we've seen before. For example, this straight line down here, I told you guys that you read that straight line as a such that. The new thing that we haven't seen here is this arrow head right here, this bar with an arrow, which means x is mapped to match to 3x plus 2. Okay, so we're gonna be looking at things like this today. And so with that being said, we start with the first problem. Okay, we're given the function f of x equals to 3x minus 5. And they want us to find f of 4. Okay, so that means that this right here, okay, is our output value, and this right here is going to be our input value. Now, yes, you do have the f of x here, but if you look at this f of x, my input value is just going to be x, which doesn't make anything of a difference with the output value because I already have the x right here. So what I'm going to do is that I'm going to replace this x with this value of 4, since this is what I'm trying to find. Okay, so I'm going to go ahead and I'm going to get f, but instead of x, I'm going to put 4 to equal to 3x minus 5. Okay, So if you notice here, what used to be in the place of the 4? Well, I used to have an x, right? But now I replaced the x with 4. Okay? Now, the reason I replaced x with 4 is because that is exactly what this problem told me to do. Okay, it didn't tell me like directly, but it did tell me using the notation of the problem. Okay, so what that means is that I replaced x with 4, so that is exactly what I'm gonna do with the rest of the equation. So that means that wherever I see an x, I shouldn't see an x anymore. I should see it being replaced with a 4. So if I do that, I'm gonna get f of 4 equals to 3 times 4 minus 5. Okay, and then after that, you just solve it. And you go ahead and do 3 times 4. Well, what's 3 times 4? 3 times 4 is 12. And then what's 12 minus 5? And the answer to that is 7, right? So that means that f of 4 equals to 7. So you can actually represent this answer as an ordered pair, because like we said, this right here is my independent variable, right? So you can go ahead and say that your ordered pair for this is going to be 4, 7. Right? Because this is x and that equals to y. So you can go ahead and say that that right there is your answer. Because when are you going to get 7? The only time that you're going to get 7 for this exact problem is when x equals to 4. And so therefore that right there would be your answer. Now you can also do this not only for numbers, you can replace it with variables as well. So let's go ahead and do example number 2. Okay, so we are going to find the value of h of b equaling to 3b squared minus 2b plus 1 when b equals to -3. Now, do you have to use f and x and y all the time? No, you can switch it up and use different variables. For example, h of b. So that means that h used to be f and b used to be x. So once again, right here, this right here will be your input value. Or this right here, which is the b. And then this whole situation right here will be your output value. So let's go ahead and rewrite this where I replace b with the value of -3. So do notice the different ways that they've written these problems, right? So we're going to go ahead and we're going to get h of -3 equals to 3b squared minus 2b plus 1. So that means that we're going to replace every b value with -3. So that means that I should not see any more b's. I should see wherever I have a b, I should see a -3. So we're going to go ahead and we're going to get h of -3 equals to 3 times -3 squared minus 2 times -3 plus 1. So wherever I put those parentheses, I'm going to go ahead and place a -3. You should just, get used to using parentheses, especially when you have like a negative raised to the power of 2. Just get in the habit of using parentheses, And then we go ahead and we solve this. So h of -3 is going to equal to negative 3 squared, because you have to use parentheses first. Negative 3 squared, that means a negative 3 times a negative 3, which would be a positive 9. And then negative 2 minus 3 would be a positive 6 plus 1. Okay? Okay, so now we're going to go ahead and do 3 times 9. 3 times 9 is going to be 27 plus 6 plus 1. All of that added together is going to give you 34. So your answers here is going to be negative 3, comma 34. Okay? We're going to go ahead and move on to example number 3. But that's the general idea here, guys. Okay, you're just inputting values into the problem. So we're going to go ahead and we're going to find g of 2w when g of x equals to x squared minus 2x plus 1. Okay, so once again, see the different formats that we're using to write these problems, right? So right here, this right here is my input value. And this right here is going to be my output. So that means that now I added a variable as well. So that means that every x will be replaced with 2w. So that means that wherever I see an x, I should not see an x anymore. I should see a 2w, right? So that means that we're going to get g of 2w equaling to x squared minus 2x plus 1. Okay, so that's the initial format, 2w. So now every single x, like we said over here, is going to have to get replaced with 2w. So if I rewrite that, I'm going to go ahead and have g of 2w equaling to 2w squared minus 2 times 2w plus 1. So wherever I have the parentheses, that's where I'm going to put the 2w. And then after that, you literally just solve the problem using PEMDAS, because we're not trying to solve for x. We're just simplifying the problem, so you can go ahead and use PEMDAS here. So that means that in this situation, we're going to have 2w squared. Okay, so if you get confused with what a 2w squared would look like, you can literally just write it out, right? You would have 2w times 2w, because when you have something squared, it means that you're multiplying it times itself twice, right? So here I would go ahead and have negative 2 times 2w will be negative 4w plus 1. So now a 2 times 2 will be 4, and a w times a w will be a w squared. So g of 2w will equal to 4w squared minus 4w plus 1. Okay, and so then that right there will be my answer. And just note, okay, note the answer is in terms of w. Okay, so just keep that in mind. And then once again, just use parentheses. Parentheses can reduce or prevent the algebraic errors. So once again, I will stick with that. Just use parentheses. Okay. Now we're going to go ahead and we're going to go to the last and final example. Now, I know I haven't talked about domain and range, so we'll go ahead and consider this part 1 of the lesson, and then we'll deal with domain and range as part 2 of the lesson. Okay, so for example number 4, we are given f of x equals to 2x squared plus 4x minus 3, and we want to find f of 2a plus 3. Okay, so once again, this right here is your input value, because that's what you're going to put in to the equation, and what you put in, that right there should give you the output value. Okay, so that means wherever we have an x, x is going to be replaced with 2a plus 3. Okay, so we're going to go ahead and we're going to replace every single x with 2a plus 3. Remember, use parentheses, okay? So we're going to go ahead and have f of 2a plus 3 equals to 2 times 2a plus 3 squared plus 4 times 2a plus 3 minus 3. So wherever I have the parentheses, I should go ahead and put 2a plus 3, 2a plus 3, and then 2a plus 3. So now we go ahead and we do PEMDAS. So that means that I'm going to get f of 2a plus 3. And once again, if having a 2a plus 3 raised to the power of 2, that I would recommend the way to evaluate that would be to just write it out. Okay, so that way you don't make errors, and you just make sure that what you're doing is correct. So now we're going to do 4 times 2a. Well, what's 4 times 2? That's 8a. 4 times 3 is 12, and then minus 3. Okay? So now you can also just combine like terms right now. So 12 minus 3, that's going to give you 9. So when I rewrite it, that's what I'll do. I'm also just going to go ahead and go straight into the multiplication of the 2a plus 3 that I had raised to the power of 2. This 2 right here in the front, that doesn't get evaluated until after you evaluate those two parentheses. So I'm going to go ahead and have 2a times 2a, which is going to be 4a squared, 2a times 3, which is going to be 6a, 3 times 2a, 6a, and then 3 times 3, 9, plus 8a plus 9. You can also combine these two terms right here to give you 12. So you're going to get f of 2a plus 3 equals to 2 times 4a squared plus 12a plus 9 plus 8a plus 9. So now you have to go ahead and distribute this 2. So 2 times 4 is going to be 8a squared. 2 times 12 will be 24a. And then 2 times 9 will be 18 plus 8a plus 9. Now, I don't need the parentheses anymore because I already distributed the 2. So all you have to do from here is combine like terms. That'll be 24a plus 8a and then 18 plus 9. And that right there will give you the answer of f of 2a plus 3 is going to equal to 8a squared plus 32a plus 27. Okay, and that right there will be your answer. And that'll be part 1. We'll continue.